Hello, and a very good morning to everyone. I hope I am audible and visible to everyone. Am I audible and visible? Everyone can hear me and see me. Great. So I welcome you all to this so-called new look physics class. As I keep on telling you, we should always try new things in life. We should always try and improve ourselves. So I've been improvising on something, and I'll be taking your classes from now onward on this board. This is a better one than the other one that was I using. Before starting the class, again, I will repeat the same instructions. Keep your videos off. And if you have got to ask anything, use the ID with the name of state. That is where I am for your chats. Good morning, everyone. Everyone has wished me good morning. I was not able to respond to you personally, but again, I wish you a very good morning and a safe day, year, and life ahead. Now, coming on to what we were doing in the last class, as far as I remember with my short memory, that we were discussing equations of motion, isn't it? We were discussing equations of motion. Good morning, Siri. We were discussing equations of motion with constant acceleration. We had done some problems on it, 2 or 3 problems on it. Yes, Santosh, we had done some problems on it. If I remember correctly, I had given you a problem to solve at home. This is the problem. It was question number 3 that we were doing. So now, to start off this class, we will start with the same question. I will repeat the question once again. This is the way you will see question in your books. A body moving with a velocity 6 meters per second. It is not given in which direction. So you'll have to assume some direction. You can always assume the direction as positive x. Has a retardation. I hope we all understand the meaning of retardation. The direction of acceleration is opposite to the direction of velocity. So if the velocity is along plus x, acceleration has to be along minus x. We'll call it retardation. It will slow down the body. After 4 seconds, we are supposed to find out v, means final velocity after 4 seconds, delta r, displacement, l, length of the path, distance, v dabba, average velocity. I hope you can all try this question. Can I have answers to part number 1? Part number 1 is finding out the value of v. What is the hint to part number 1? Hint to part number 1 is very simple. We have to use which equation? Anyone? For part number 1, minus 2 meters per second. Santosh has given me the answer. I think that is the correct answer. I was about to give the hint. No one wants hint, I think. V is equal to u plus at was the hint. You put the values with proper signs and you should be there with an answer. Let us see what is the answer. How do we get it? Initial velocity u is 6 meters per second along positive x, so I'll write it as plus 6. Acceleration is 2 meters per second square retardation, so I will write it as minus 2. Time is given as 4 seconds. It's very easy from here on. You have to just apply v is equal to u plus at, so v will be equal to u is plus 6 plus acceleration is minus 2, time is 4 seconds. So I put the values of all the variables here and I got the answer as minus 2 meters per second. If you have got this answer, you must congratulate yourselves that you have passed the first exam, that you are now ready with equation number 1. Can I have raised hands of all those students who could solve this question on their own? Only 4. That's very sad. Okay, the number is coming up. The number is coming up. 15. Only 15. What about the others? If anyone does not understand this question, please tell me, please ask me the doubts. The podium is open. Okay. I'll ask everyone to lower your hands And that was my question number 1. Question number 3, part number 1. Now let us move on to the second part of finding out the displacement. Anyone could do part number 2, finding out displacement. There are different ways in which I can find out the displacement. There are different ways in which I can find out the displacement. Anyone can tell me which way should I use? I can use the direct equation. Santosh, you must also understand that Raju, displacement is a vector quantity. So always talk about the direction as well. If you don't talk about the direction, then you are missing the point. You are killing physics. Don't kill physics. Hint can be anything. Let me write a hint. I can write to find out displacement delta R. You can use this equation ut plus half a t square. You can use this equation. Yes, Santosh, now you are correct. Plus is important. You can use this equation, or you can use this equation. V square is equal to u square plus 2 times acceleration into delta R. You already know the value of V, you already know the value of U, you know the value of A. You can find out displacement from here, but I will not use any of these two. I will not use this one, I will not use this one. I will use my favorite. Which is my favorite? My favorite is, first I will find out what? First I will find out V average. First, I will find out V average. So I'm doing it in a third way, which I want you to also understand and remember it always. I'll find out V average. How will I find out V average? Because as you can see in the question, there is also question number 4, where you have to find V average. I want you to insist on this V average because it is very simple and it is very elegant. And you will see that this V average is going to help you a lot. That is why I'm asking you to use this V average. You can use equation number 1 or equation number 2. Anyways, you will get the answer, but I will get the answer in the third way using V average. What is V average? V average is final velocity plus initial velocity divided by 2. We just need to put all the values. The initial velocity, the final velocity was -2 plus the initial velocity was +6. Now you could be wondering, sir, why are you writing plus here? It's already understood that it is plus. Remember, beta, we're talking about vectors. Without plus or minus, you will lose the essence of vectors. Do not kill physics, use science. -2 plus 6 means velocity, initial velocity divided by 2. Now what is the answer here? So it will be 4 divided by 2. So my average velocity will be +2 meter per second. So we have solved part number 4 first. Can I have some raised hand that, sir, we understand what you are doing. You are not using the direct method. You are using the indirect method because you want to make the students understand something that you can be done in a different way. So I found out V average. Now tell me, how will I get displacement from here? How will I get displacement from V average? Tell me, anyone, how will I get displacement from V average? My purpose was to find out displacement, not V average. I found out V average, intermediate step. How will I find displacement from here? Anyone, how will I find displacement from V average? Waiting for your answers. How will I find displacement from V average? Anyone can help me with this? You have to remember the definition of V average. You have to remember what is V average. V average was displacement divided by time, total displacement divided by time. Remember, oops, what I've written delta. V average, the other formula was total displacement divided by total time. Just remember these, students. Beta, remember this. Yes, total displacement divided by total time. So from here I can find out displacement. From here I can find out displacement. Yes, Santosh, you are correct. Displacement will be V average multiplied by time. I just use this simple formula, the simple multiplication. No square, no ut plus half at square, no v square. I don't have to square things. I'm very bad in maths. If I square, I forget. Multiplication and addition is simple for me. So V average is plus 2 multiplied by how much was time? Time was 4 seconds. My answer is plus 8 meters. Plus is very important here. Plus is very important here because this plus is telling me what? This plus is telling me what? Anyone? What is this plus sign telling me? It is telling me the direction of the body, that the displacement is in the positive x direction. Yes, Anna, yes, Chaturya, everyone is correct. It is moving along positive x, always write plus. So we have done part number 1, we've done part number 2, question number 2. We've also done question number 4. The only thing that remains is question number 3, which is the toughest part. Find out the length of the path. Length of the path, meaning we have to find out the distance traveled by this body, L, the distance traveled by this body. But I always tell you, in no equation we have distance. To find out distance, we must understand how the particle has moved. So now I'll give you a minute to win it. Anyone can tell me what is the distance traveled by this particle? You will have to draw a diagram. Without diagram, nothing will work. So that would be my hint for question number 4. Draw a diagram and see what is happening. Anyone can help me with this? Anyone can get the answer for this one? I would be very, very pleased. Okay. I'll do my part a bit since I'm your physics teacher. I'll draw the diagram and see what has happened. Now, looking at the final velocity was coming as -2. That means it is coming back. That means at some point in time, it must have stopped and then turned back. That is what I'm going to draw here. I am drawing a straight line. This is a straight line. This is point A. It started this journey from point A. Then it reached point B. At point A, its initial velocity was plus 6 meter per second. Plus 6 meter per second. Its acceleration was retardation, so it was backwards. Acceleration was -2 meter per second square. That means it would have stopped. And I'm assuming that it has stopped at this point B. So its velocity at this point B becomes 0. Then it would have turned back. And as you can see, the final velocity is negative. So it would be somewhere here. It would be somewhere here at point C. And it is moving backwards. It is moving backwards. And its velocity is -2 meter per second. So now I have drawn this diagram, which is a hint to you guys. You have to tell me the total length of the path. You have to tell me the total distance. Can anyone tell me from the diagram what is the total distance traveled by the particle? Can anyone tell me from the diagram what is the total distance traveled by the particle? Looking at the diagram, can anyone tell me what is the total distance L which is traveled by the particle? First the particle was at A, it went till B, and it turned back, and now it is at point C. Can you anyone tell me what is the total distance traveled by the particle? What is the total distance traveled by the particle? The length of the path. So first it has gone from A to B. So you have to find the length of the path AB. Then it has gone from B to C back. So you'll have to add BC ka length. When you add AB with BC, you will get the total length of the path, which is the total distance traveled. Am I clear with this point? First, the particle was at A, it was moving forward, acceleration was backwards, slowed down, slowed down, slowed down, slowed down. At point B, it stopped, came back. It is same as throwing this pen up. At some point it will stop, then it will come back. So right now it is at point C. We have to find out A to B, the length, and B to C, the length, and add them and get the distance. Can anyone tell me what is A to C? What is A to C? A to C is the displacement that we have already calculated. Am I clear with this? We have already calculated the displacement from A to C, yes or no? And how much was coming? It was coming as +8. That means the length of the path from A to C is 8 meters. Is everyone getting me? We have already calculated our displacement. Initial position of the particle is A. Final position of the particle is C. We have calculated the displacement from A to C, and it is coming as 8 meters. So now you have to find out the distance from or displacement from A to B. So what I'm going to do is I am going to write equation from A to B. A is the initial point, B is the point where it has stopped. Now, look at this, everyone. The initial velocity at A is +6 meter per second. The velocity at B is 0 meter per second because it has stopped. The acceleration is -2 meter per second square. The acceleration is -2 meter per second square. From here, I can find out the displacement. How much is the displacement? Can anyone tell me how much is the displacement from A to B? Which equation I should use? I can use the direct equation. V square is equal to U square plus 2 times A into delta R. V is known, U is known, A is known. You can find out the value of delta R, which is the displacement from A to B. Do we understand this? Why we have to do all this? Do we understand this, beta, everyone? Can I have some raised hands that so we understand what we are doing? Can I have some raised hands? Yes, Deepak says yes. 12, 15, not all are responding. Let me ask. Finally, okay, great. So many people responding. Likhit, Anil, Varsha, Manasa, Charita, Satvika, Goli, Jay, Jyotsna, Kevin, Shashank, Maruti, Rakesh, Sana, Surendra, Harshita, Tarun, Venkatajay. What about you? Have you understood this? Great, I've got around 30 out of 50. I think maybe the rest, oh, more than that. Great. So now you can just calculate the value of displacement delta R. Give me an answer, fatafat. Give me an answer quickly. This final velocity is 0. Initial velocity, let us see, it is +6. +6 squared is 36 plus 2 times acceleration is -2 multiplied by delta. Chalo bachcho, give me the answer for delta. How much is delta coming? This is from A to C. Tell me the answer. How much it is coming? Someone has sent me message over here. Please don't send me message beta here. Rakesh, please send me message on the other ID beta. This is not the ID that you send message. Please send me message on the Astic ID, not on the Astic Udini ID. He has given me the correct answer though. That is +9. You missed 9. You please miss plus beta. Please don't miss plus. Plus is the direction. -32, Anak. No, Anak. It's not -32. It's +9 meters. Am I clear, everyone? 36 will go here, it will become -36. -36 divided by -4 would be +9. So now I'm going to mark it. Now I'm going to mark it with my white pen. So I'm marking it with my white pen. A to B, the total length. A to B, the total length is 9 meters. But that was not my question. That was not my question. My question is, what is the total length of path? Sorry, my question was, what is the total distance traveled by the particle in 4 seconds? So now you know something is 9 meters, other thing is 8 meters. What is the total distance traveled? No, Yashwant has come up with the answer. It is 10 meters. Raju is also correct. Chaturya +1. How did you get +1 beta? Please apply some sense. Physics is all common sense. Yes, Deepak, you are also correct. From A to B, the total length is 9 meters. From A to C, the total length is 8 meters. So B2C becomes 1 meter beta. Please listen. B2C becomes 1 meter. So now look at the question. The particle was at A. It started its journey. It reached point B. At point B, stopped. Total distance traveled is 9 meters. Displacement is plus 9. Then it came back 1 meters back to point C. Displacement becomes plus 8 meters. But the distance traveled becomes 9, which is AB, 9, which is AB, plus 1, which is BC. So my total distance L traveled by the particle from 0 to 4 seconds becomes 10 meters. Am I clear with this? What I have done over here, I will ask anyone who has not understood this question to please raise hands now. Again, I will repeat the entire question in its totality. Please have a look at the whiteboard. I mean, that's a blackboard now, not a whiteboard. The first question was find out the final velocity after 4 seconds. We use the simple equation v is equal to u plus at. Put the values, get it done. The second question was find out the displacement delta r. There are 3 different ways. Either apply ut plus rvt square or v square is equal to u square plus 2a delta r, or my way, find out the average, then multiply this average velocity by time. This is my favorite. I use this. If you want, you can use this. Plus 8 meters was the displacement. Then we came to the most difficult part, which is finding out the distance traveled by the particle. Think about the path, think about how it has moved. It was at A, stopped at B, came back to C. From A to B, we found out the displacement. Displacement was plus 9. Distance traveled was 9 meters. B to C, 1 meter. And we are done. Total distance traveled is 10 meters. Let me take a deep breath. Anyone with a doubt, please raise hands. Else we'll move on to the next question. So I'm giving you a chance of asking your doubt. Else I will move to this one. And here is this. This is taken from your notes. Okay, Deepak, I'll take your words for the entire class. Sample problems on uniform acceleration. You must have seen this. This is in your notes. Problem number 40 is what we are going to discuss now. The problem is very simple. A body A moves with a uniform acceleration and 0 initial velocity. Another body B starts from the same point, moves in the same direction with a constant velocity v. So there are 2 bodies A and B. A starting from rest, moving with an acceleration A. B starting with the same velocity, uniform velocity v. The 2 bodies meet after time t. You have to find out the value of time t. 1 body, 2 bodies, they are meeting after time t. You have to tell me the value of the time t. Am I clear with this question? Am I clear with this question? So now is the time that you solve this one. Solve this question. How to solve this one? How to solve this one? How to solve this one? So you draw a simple diagram. This is question number 40, I think. Question number 40. Two bodies. Let me draw a straight line. Where is the shape? Let me draw a straight line. This is my straight line. Two bodies start from here. Let me call the first body. Let me call the first body as A. It starts with a initial velocity 0. It starts with an acceleration A. The next body is B. It starts with a uniform velocity V. These two gentlemen start from the point X. They are supposed to be meeting at the point Y. After how much time do they meet? First body starts with 0 velocity, acceleration A. Second body moves with a constant velocity V. And your time starts now. Your time starts now. Do you want a hint? Anyone wants a hint for this one? Or you can solve it on your own? I must tell you that we did this question in the NEET batch and students were able to solve this on their own. So I guess that you are from the JEE batch. You must be able to repeat their feat. If you have not understood the question, please ask. I can make you understand it. So after how much time do they meet is the question. Two bodies A and B, A with 0 velocity uniform, 0 velocity initially with an acceleration A, B moving with the same velocity B, V. After how much time do they meet? Anyone with an answer? Two V by A, yes, Deepak, that is the answer. 2V by A, great. You have done a good job. If you have done this question, then you have to also tell me what is the total distance traveled by the two bodies. That is an additional question. After finding out time, find out the total distance. After finding out time, find out the total distance. How to do it? Hint. What is the hint? What is the hint? They start from the same point. When will they meet? When they meet, their displacements must be same. So displacement of body A must be same as displacement of the body B. This is the hint. After this hint, let us see how many of you can solve this. Both the displacement must be same. The displacement of body A and the displacement of body B must be same. Can you now solve it and get me the answer? Displacement of body A and displacement of body B must be same. Can anyone now give me an answer? Okay, let us find out the displacement of body A. Let us find out the displacement of body A. It is ut plus half at squared. Initial velocity of body A is 0. Acceleration of body A is A, small a, and it takes time t seconds. This is the time that you need to calculate. So displacement of body A becomes half at squared. Do we agree on this? Everyone? Anyone has a doubt on how to find out the displacement of body A? Please raise hands. Anyone has a doubt? Please raise hands. Now, since we have calculated the displacement of body A, let us now quickly find out what is the displacement of body B. So the displacement of body B, again the same formula, ut plus half at square. But here, initial velocity is given as v, great, time is same. But the acceleration is 0 because the body is moving with a constant velocity. So displacement of the body B is V. I should write plus V here. I should write plus half AT square here because plus indicates the direction. Now both the displacements are same. You can equate both V into T, sorry. You can equate both the displacements. So what do you get when you equate both the displacements? You will get the value for time T. So displacement of A must be equal to the displacement of B. Half AT square must be equal to V multiplied by T. One T can be cancelled out. So my T will be equal to 2V by A, and that is your answer to this question. Am I clear? How did I get this answer? Anyone has any doubt, please come up. Clear, okay. Now the second question that I have made is, what is the displacement of the two bodies? So basically now I'm asking you, what is the value of displacement of A, or what is the value of displacement of B? Now I'm asking you this. How can you find out the displacement of the two bodies? How we can find out the displacement of the two bodies? Can anyone give me an answer to this one? What is the displacement of the two bodies? Question number 2. Part 2. What is the displacement of body A, or what is the displacement of body B? Both are same. Both are same. How will you get it? V is the displacement. No, beta. V is not the displacement. What is the displacement of body A, or what is the displacement of body B? To find out the displacement of body A, what we got to do is just write the formula. The displacement of body A is half AT square. Half AT square. You can use this half AT square. You know the value of time is 2V by A. So half AT square may just put the value of time half into A. Time is 2V by A. You square it and you will get your answers. And your answer, I think, will be 2V squared by A. Am I correct? Anyone got this answer of displacement of body A? 2V squared by A. Or you can find out the displacement of B and also check. Displacement of body B will be V multiplied by T. V is V multiplied by T. Just put the value of T in this equation. The value of T is 2V by A. So you calculate it from this equation also. Your answer will be coming same. Look at this answer, displacement of body A, or look at this answer, the displacement of body B. Both are same. They should be same and they are coming same. Do we understand this, how we have done this? The question was, when are they supposed to meet? When they meet, displacement must be same. We found out the displacement of A, we found out the displacement of B, equated them, got the value of time. Time was 2V by A. Then we put the value of time. Then we put the value of time in their equations. In their equations of displacement, we put the value of time everywhere and we got the same answer for their displacement. That was question number 40. Am I clear with this question? Anyone has a doubt, please raise. Anyone has a doubt with this question, please raise your doubts now. Anyone has a doubt with this question, please raise your hands now. Else we will move on to the next question. And the next question is here. Can you see this question now? This is question number 43. 43. Do you see this question? Question number 43. A car, no, 43. A bullet of velocity is reduced from 200 to 200 to 100 meter per second while traveling through a wooden block of thickness 10 centimeters. What is the retardation of the body? Do we get this question? Question number 43. Question number 43. A bullet which is moving with a velocity of 200 meter per second is traveling through a wooden block and the velocity decreases to 100 meters per second. We have to find out its retardation. Block के अंदर bullet has gone inside. You have to find out what is the retardation of the body. Your time starts now. Your time starts now. Let's see who gives me the answer first. Let's see who gives me the answer first. Let us first draw a simple diagram of what is given in the question. Question number 43. Let us draw a simple diagram of what is given in the question. So what I'm going to do is I'm going to this is a wooden block. Let me make it solid. So this is a solid wooden block. A bullet enters it. Let us say at this point. It is moving. This is point A. It is moving with a velocity 200 meter per second. Let me call it as plus because it is moving in the positive x direction. Then it reaches point B. It is still moving forward. The velocity is plus 100 meters per second. You have to tell me what is the acceleration of the, they have called it retardation, but as I said, retardation is not a correct word. What is the acceleration or retardation of this bullet? I'm waiting for your answers. Let's see who gives me the answer. Let me see your chat. I hope you have not missed this. Okay. So initial velocity is given, final velocity is given, and it has moved a distance of 10 centimeters. This is also given. It moves the distance of 10 centimeters. That is also given. While it has moved a distance of 10 centimeters, its velocity has reduced from 200 meter per second to 100 meter per second. And Santosh is there with an answer, 15 multiplied by 4 meter per second square. Santosh, you might also say negative because it is retardation and it is opposite to velocity. Whenever you're talking about vectors, please tell me their direction, else you are killing physics. Don't kill physics. Physics is a good subject. The answer is absolutely correct. Santosh, can you give me a hint of how you have solved this? So I'll ask you to unmute yourself. Let me see. Oh, I just can't do it. Let me see. Let me see if I can unmute you. Okay, Santosh, unmute yourself and tell me how you have done this. Santosh, can you hear me? Okay, he can't unmute himself. Not a problem. Santosh has given me the answer in the chat. Great. So the hint is very simple. Velocity is given. Final velocity V. This is not final velocity. Final velocity is at point B. It is given as plus 100. I will not write the unit. Initial velocity U is the velocity at point A. It is given as plus 200. Great, Yashwant, you are correct. I think you have missed 10, Yashwant. Please check. The displacement, remember it is given in centimeters, beta. Don't forget centimeters. It is not the SI unit. Everything has to be in SI units. How much is 10 centimeters? 10 centimeter is 0.1 meters. Please don't forget this. Displacement is 0.1 meters. Just put the formula. V square equates U squared plus 2 times A into delta R. Just put the values. Final velocity is 200. Ting, ting, ting. Initial velocity is 100. Ting, ting, ting. Displacement is 0.1. Simple math, simple equation. You should be getting the value of A. And what is the value of A? What is the value of A coming as? The answer given in the sheet is 15 into 10 raised to the power 4. I would assume that they have done it correctly. I have done it correctly in the sheet, that meter per second square. Do we get the same answer, everyone? With a negative sign, I must add, this negative sign indicates that the direction is opposite to the direction of velocity. That was question number 43. Clear to everyone? Please, anyone who has not understood this question, raise hands. I will wait for you. Else, I will move on to the next question. We are clear with this, everyone? Clear. Now, the rest of the questions, I think you should be able to solve on your own. Else, we'll discuss some of them in the next class. There is one more small topic that I need to cover today, and quickly we will move on to that small topic. Can anyone tell me what is the name of this small topic that we are going to discuss now? Can anyone tell me what is the next thing that we are going to discuss? We are going to discuss equations of motion under gravity. Oh wow, Deepa, great. And I didn't think that anyone would be able to guess. I'm very happy, Deepak, that you could guess. If you could guess what is coming next, you are prepared for it. Great one. Good one, Deepak. I'm very impressed, very happy. Equations of motion under gravity. Now we'll take a pause and try to understand what is gravity. Anyone can tell me what is gravity? Anyone can tell me? We have already discussed it in the first classes that we did. Can anyone now recollect what is gravity? No one? Force applied by Earth. Yes, that is correct. We can call gravity as gravitational force of Earth. Gravitational force of Earth. We are living on this planet, Mother Earth, and our Mother Earth is attracting each one of us, each object. In fact, our objects which are near to Earth, moon and satellites and everyone, Mother Earth is attracting each one of us with a force which is known as gravitational force of Earth. Gravitational force of Earth is also called by the name of gravity. There was a movie starring, I think, I forgot his name. Gravity was the name of a movie. Now, because of this gravity, because of this force, whenever someone exerts force on the other body, the body accelerates. So because of this force, everyone, all the bodies accelerate. Look at this body. It's hanging here, I'm holding it. If I drop it, what happens? Here it is having initial velocity 0. But now its velocity is changing. It has gained some velocity. See? It has gained some velocity. See? It has gained some velocity. That means it has been accelerated. Yes, it has been accelerated. It is accelerated because of the force of gravity. Yes, Anak, 9.8 meter per second squared. You have written meter per second. It is accelerated by the force of gravity. And that acceleration, yes, we are coming to the same point. That acceleration is known as acceleration due to Gravity. The acceleration that gravitational force or gravity of Earth produces is known as acceleration due to gravity. Its value changes from place to place, even at the same place at different heights, it is having different values. But we will not get into that right now. This entire thing of gravitation will be discussed in a chapter known as gravitation that will come at the very end of your course of 11th. We'll discuss it then. Right now, at this point in time, this acceleration due to gravity for us is always going to be constant. It's always going to be constant. That means it will be constant in two things. Remember, it is acceleration. So acceleration is a vector. So it will be constant in two things. It will be constant in magnitude. It will be constant in direction as well. Even though I must tell you that G changes in magnitude as well as in direction. But for now, it will be constant in magnitude as well as in direction. Can anyone tell me what is the magnitude or what is the value of acceleration due to gravity? This acceleration due to gravity is also written by the letter small g. Small g is acceleration due to gravity. Can anyone tell me what is the value of this small g here? All of you know it probably. What is the value of this, magnitude of this? 9.8 meter per second square. Yes. Remember, it is not same. It changes from place to place, but we'll take it as 9.8. But in some questions, we might just take it as 10 to make the question simpler. Instead of 9.8, in some question, remember, Chaturthi Beta, this is not 10. It is not even 9.8 at all points. It is changing. But for questions, we will take it as 9.8 or 10, or in some cases, we will simply take it as G. There will be some questions which you call it alphanumeric questions in which we will take it as G only. So 9.8 or 10 or G, all are values of acceleration due to gravity. Am I clear with this concept? Can I have raised hands? Am I clear with this concept? Everyone understand that G is constant, will be taken as constant. It is not constant, will be taken as constant. What about the direction of this G? Again, the direction also changes at different points. Trust me on this. But right now, at this point in time, what is the direction of G that we will take? Downwards, yes. It's actually not downwards, beta. It's towards the center of Earth. It's actually not even towards the center of Earth. It's somewhere in between. But now we will take it as downwards. Am I clear? So we are assuming that G is constant. It is not constant. We are just assuming it. Right now, we are assuming that G is constant in magnitude as well as in direction. Direction is downward, and magnitude is, in some questions, 9.8, in some questions, 10, in some questions, simply G. We've discussed this much, but we have still not discussed the equations of motion. Let us now get on to the equations of motions for motion under gravity. And what is the first equation of motion for motion under gravity? What is the first equation? Anyone? What is the first equation for motion under gravity? Waiting for your answers. No one? Okay, I will help you. V is equal to U plus AT. That is the first equation. But instead of writing A as A, we know that acceleration is going to be G. So instead of writing A as A, we will write it as G. Do we understand this? This is the first equation of motion for motion under gravity. V is equal to U plus GT. Now remember, this equation or all the equation must be used with proper sign conventions. Many a times, many students have this doubt, sir, what is the sign of G? When I am throwing a ball up, is G positive or G negative? When the ball is coming down, is the G positive or G negative? What should I take, sir? I don't understand, sir. When the body is going up, Is G positive? When the body is coming down, is G negative? Who can give me an answer to this one? When is G positive? When is G negative? Suren Nath has come for first time. Welcome Suren to the class. And Suren says, which I would also, Santosh says down positive, up negative. Suren says upside positive, upside negative. Everyone seems to be confused. Chaturya says up G is negative. What about down? When the body is moving down, is G positive? Everyone knows that when body is moving up, G is negative. What about when body is moving down? What about G then? Down is also negative. Remember beta, G is always negative. Because when the body is going up or when the body is coming down, G does not change. G is constant. Remember, G is constant. G is always constant. G is constant. G can't change. G can't change. G is always negative. According to our sign convention. What is our sign convention? Anything, any vector which is directed upwards is positive. Any vector which is directed downwards is negative. G is always downwards and hence G is always negative. Let me repeat. Even if the body is moving up or the body is moving down, G is always downwards. G does not say change. And hence, for our questions, G is always negative. Do we understand this? Can I have a raise of hands? Sir, we understand this. No matter how the body moves, G is always negative because G is always downwards. We will not take it positive anytime, anywhere, we will not kill physics that one time it is positive, other time it is negative. No, that is killing physics. We will not kill it. We are not killers, we are learners. Can anyone tell me what would be equation number 2 with proper sign convention? What will be equation number 2? Equation number 2 for motion under gravity. Waiting for your answers. No one knows equation number 2. See, nothing has changed. Equation don't change. Equation remains same. R is equal to ut plus half gt square. Let us call it delta R. Displacement delta R is ut plus half gt squared. Same equation, whether the body is going up or the body is going down, G is always negative. Please remember it, beta. Don't change the sign of G. Just remember our sign convention. Our sign convention says that anything which is, any vector which is upwards is positive, any vector which is downwards is negative. We don't change it for anyone. It remains same. What about equation number 3? What is equation number 3 for motion under gravity? Gravity, the acceleration is taken as constant. What is equation number 3? And I'm waiting for your answers. No one knows equation number 3? V square, yes, Santosh. V square is equal to U square plus 2 times G into delta R. I understand that writing delta R in the chat is not good. So you can write S, doesn't matter, but I understand that you understand. Don't write delta R, it becomes big. You can write S, and I'll understand S is displacement. I understand that. But I will always write delta R. I have short-term memory loss. I forget what is displacement. I start to think that displacement is distance, shortest distance, shortest distance, shortest distance, short-term memory loss. I kill physics. I don't want to kill physics. So for my own brain, I write delta R. Delta means change, R means position, change in position vector. That is displacement. It's for me. I can't remember it. If you can remember it, you can write it as this. Equation number 4. What is equation number 4 for motion under gravity? Waiting. No one knows equation number 4. This equation will help you a lot in these questions. We have not done this equation, beta. We will do it in the class tomorrow. Probably. We'll do that equation in the class tomorrow. Fourth equation is, yes, Santosh, you are following me correctly. V average. Remember this equation is V plus U by 2. This equation is going to be a SOS. You know the meaning of SOS? SOS. I was a mariner once in a lifetime. Some lifetimes back, I was a marine engineer. SOS is a message that is sent when the ship is sinking and when there is distress everywhere. You are panicked. I never had to panic. We never send the SOS. SOS means save our souls. That's a distress message. Save our souls. Save our souls. So this is a SOS. This is what a SOS means. Save our souls. God save us. This equation is SOS actually. This is SOS equation. This will save your souls when you are stuck. This equation will help you out. That is why I'm insisting on this equation. SOS. Remember, these equations are only valid because acceleration, which is G, is taken as what? Is taken as a constant. Am I clear with this concept that since acceleration, which is G, is a constant, we can write these four equations as equation of motion. Anyone understand this? Please raise your hands if you have any doubt in any of the equations that we have written, because if you have understood this, we shall move on and solve one question on motion under gravity. Are we ready for the questions? Question number 1 for motion under gravity. Here is the question. A ball is thrown up. Now my question would be very elaborative. And in one question, I'll ask everything that is possible. So with one question, we are not solving one question, we are probably solving 5 or 10. That's why it takes time. But then we cover everything that is there, every question. A ball is thrown up with a velocity 20 meters per second. Take G as 10 meters per second square. So I mentioned it. In my question, always take G as 10 meters per second square. A ball is thrown up with a velocity 20 meters per second. G is to be taken as 10 meters per second square. Find out number 1, H max. Number 2, T up. Number 3, T down. Number 4, total distance, total L. Number 5, velocity with which velocity and speed with which it strikes ground. So I have made almost all questions that are possible in this. The baton passes on to you. So I hope my writing is good enough for you to read it. I have a ball. This is not a ball. I have a ball, throwing it up with a velocity of 20 meters per second. G has to be taken as 10 meters per second square. It will go up, 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 up. It will reach a maximum height. At this point, the velocity becomes 0 for 1 instant. Then it goes down. H max means the maximum height it goes up. I hope you understand this. H max means the maximum height it goes up. T up means the time taken to go up. T down means the time taken to come down. Total L means it goes up, it comes back. What is the total distance traveled? Then the last is find out the velocity and the speed with which it strikes ground. So when you throw something up, it comes back and falls on ground with what velocity and with what speed it has fallen back on the surface of Earth. This is the question that you got to solve. Solve it as a homework. Try it at home and put your answers in the Telegram group. Am I clear with the question? Anyone has any doubts with the question? Please tell me. Anyone has any doubts with the question? Please tell me. Now, apart from that question, you also solve this solved example that you can see in your notes. These are solved examples starting from question number 40. Question number 40 we have already done in the class. So apart from question number 40, there are questions starting from question number 40 and going till question number 50, I think. Question number 50 is uniform acceleration, finishing there, as you can see. Then you have a section of motion under gravity. So look at this section. We will do it in the next class. This section, and just leave this section. Do not read it. You can solve the questions starting from question number 51 and going till question number 68. So 51 till 68, you have to try and solve 50 to 60 and 61 to 68. That 40 to 50 and 51 to 68. Do it in your classwork. Do it in a rough and then see your answers. Questions are already solved. You can check your solutions. Try your DPP as well. Someone has said something that I missed. Someone said something. Sir, I don't understand question number 5. Question number 5 is when it falls back, before falling, what is the velocity and speed of the particle? We will discuss that question in the next class. Don't worry. As far as having the blackboard is concerned, it is literally black. I will save it, don't worry. But I will share it to you. I'm still finding out ways to share it as a PDF. So I will be doing that. Don't worry. I will be sending you the blackboard in some way or another. You can have a look at the live class. Please have a look at the live class. If you have any doubts, please come up to me. I am here. At this point in time, I will dismiss the class. If you have any doubts, please ask me. Else, you can leave the class. Bye bye, beta.